Okay, so we've discussed about how the spanning tree protocol, that the first thing it does is elect a root bridge. And the root bridge is basically at the top of the spanning tree, and then it calculates all the path costs from the root bridge to the various parts of the network, or from switch to switch to switch, right? So, and then it decides which ports to put in a root forwarding state and which ports to put in a blocking state, right? So we figured out that this switch right here is the root bridge, right? Well, let's see the root bridge election process by forcing a new election, right? And that we can do that, and we can force a new election and see the spanning tree protocol kick into gear and exchange messages, or BPDUs, bridge protocol data units, and then figure out a new root bridge. So, for instance, a quick way that we could do this, right? And a quick way we can do this is by taking the root bridge and let's shut down all its interfaces. So what I'm going to do here is I'll just open up this root bridge, and it's the root bridge, the root switch, it's the top of the spanning tree, and then what I'll do is I'll just go into its interfaces here that are the trunks, right? And I'll just turn them off one by one, right? And I'm doing it not by the command line, but just by kind of cheating and using this little GUI interface, right? Okay, so that just turned off all of its interfaces right here, right? 1, 2, 3, 4, 5. Okay, and now we should be seeing a new election process taking place. So the spanning tree algorithm will have to elect a new root bridge from the switches that are remaining, right? And it's going to do it by the lowest MAC address, right? The lowest MAC address of all of the switches and all the ports that are on the switches in the network. Now, it could do it by the bridge priority number, right? But all of these switches have the default bridge priority number of 32768 plus 1 for VLAN 1, making 32769. So for instance, if I open up this switch and I do a command line interface and I hit enter, enable, show, span, tab, enter, you'll see that the root is 32769, the priority number. This is the bridge priority number. And bridge ID, this bridge is also 32769, so they're identical. And so you'll find that all the switches have the same bridge priority number, 32768 plus 1, making 32769, right? And so it's the lowest MAC address that's going to be. Now, we can see here that the root bridge has a MAC address of 005, starting 005, and this one has a MAC address 00D0. Well, this is a higher address, right, in hexadecimal than this number, right? So obviously the root bridge has a lower MAC address, right? Well, let's go find out where it is, right? Well, we could see by these ports they're pointing to the root bridge. So you can see here that, you know, this is the root port. It's green, go. This one, root port, green, go. It's going this way, right? So my guess is that this is the root bridge. Let's look over here. Green, this is the quickest way to the root bridge, not this way. Before it was the opposite. This was green and this was orange. Now they've switched. Notice when you get here, right? On this port, green here, red there, right? So it's obviously going here and here. This must be the root bridge. If we open it up and we examine it, enable, show span, tab, show spanning tree, you can see that on this switch, or this bridge, the root MAC address, root bridge's MAC address, is identical with this bridge's MAC address. Okay. Now, in the early days, when I guess switches are oftentimes called a multi-port bridge, right? That's a name for a switch, would be a multi-port bridge, right? So a bridge is a layer 2 device and a switch is a layer 2 device. So the name bridge and switch are oftentimes used interchangeably, or at least in this case it is, right? So, and you can see that the switch also doesn't have any root ports. It has all designated ports in forwarding mode. So anyway, this switch is the root bridge now, right? So let's see if we can rig the election process another way. So I'm going to go back to this switch and I'll go in here and I'll turn on all of the interfaces, right? Okay, so I did that. It was just quick to do it that way, right? So I turned on its 5 interfaces, and you can see now that it's going to renegotiate, and it's going to force an election process, and we're going to see that it will become the root bridge because now all of its ports are back up and it has a lower MAC address. Let's compare the two MAC addresses, right? So if we compare the MAC address here, right, we'll see here that this one, show span tab, its MAC address, right, is 00498, right? And so this switch, the MAC address is 004, right? Starts with a 004 over here, right, or the highest number, right? And then notice the root bridge 004, and we know that this switch had 005. So the MAC address on this switch is lower, so it became the root bridge. And now it's the root bridge once again. So also, let's try another thing. Let's go into simulation mode and do something for fun. We'll go into simulation mode here, and I'll click on Edit Filters, and I've got STP checkmarked. It's the only one I have checkmarked. If you have all of yours checkmarked, what you can do is just click off and then click STP, and let's watch the process happen, right? So click off, right? And then we'll hit Auto Capture Play, right? And now you can speed up the process by going like that, and you'll see there goes the BPDUs, right? Let's take a look at them, right? There they are. This is like running Wireshark Packet Tracer, and you can see inbound PDU details, 802.3 Ethernet, LLC, and then down here, notice what it says here, STP Bridge Protocol Data Unit, right? In there, you can see the fields. There is the root ID, then the root MAC address, the root path cost, and then look, the bridge ID, its ID, and then its MAC address, right? It's got a message, right? Hello time, right? Sending hello packets or whatever. Port IDs, max age, forward delay, but anyway, it's kind of fun to capture these packets sometimes and take a peek. But these are the BPDUs being sent out hello packets by default every 2 seconds, I believe. And there they go again, right? And there they go, right? And so being sent out, notice they're coming from, starting from the root bridge. Okay, go back to real-time mode. Let's see if we can rig the spanning tree protocol election process of the root bridge by using one of these commands here. So far we've used the show spanning tree command, but what if we changed the bridge priority number, right, of the bridge? So you can see here that all we have to do is go into global config mode, type spanning-tree VLAN 1, and then the priority number, and lower the priority number, and we could change what the root bridge is, right? You could also put in VLAN 1 root primary to just make it the primary root bridge, and then you could even put in a secondary on another switch to make it a secondary root bridge or a backup root bridge. So you could use this command, primary to make the root bridge, secondary to make a backup root bridge, or you could just change the bridge priority number right here, this number, directly. Let's give it a try. We'll open up this switch, and we will go to global config mode, right? I'm in global config mode right now. And what I'm going to do is I'll say spanning --tab tree, right? And then I'm going to say VLAN 1, right? Priority, and then I'll put in a question mark to see what my choices are, right? Now, the priority number has to go in increments of 4,096, right? It's from 0 to 61,440. Now, what I need to do is I need to make it less than 32,768, right? Because that's what it is currently. So, what if I just put in 4,096, right? Let's try that. All right, I'll try that. 4,096, right? That's lower than 32,000, right? We'll hit enter. It worked, right? Okay. Now, we'll examine, let's examine to see if it worked here. Control C, enter, show spanning tree, and you can see that this bridge now has a priority number 4097, which is 4096 plus the VLAN ID, which is 1, and now the root bridge has 4097, and this bridge is the root, right? So notice what it says here, this bridge is the root. So now we've made this bridge right here the root bridge. Isn't that curious, right? Notice how the open shutdown and open ports have changed to get to this bridge, right? Or at least they should. Possibly that negotiation might take a while to happen, but we'll see. Now, the other way that we know what happens in the root bridge election process is by the speed of the links, right? So the fact that I put a gigabit link here and a gigabit link here, right? Gigabit here, right? There's 3 gigabit links. So normally those would be determining factors, right? So let's see if we can put this back to normal. So I'll take this, I'll just put it back to normal. I'll do a conf t and I'll say spanning tree VLAN 1 priority 32768, which is the default. And I'll hit enter, right? Things will now change and this switch right here will go back to being the default, right? Control C, show spanning tree. You can see that this switch is no longer the root bridge. The root bridge is back to being the switch in the upper left hand corner.